Welcome Calculus 3 students. We are talking about directional derivatives and the gradient today. First up, we are going to try to compute a directional derivative. And what that means is we are going to compute what the function is doing at this particular point. We're going to say what that function is, if it's increasing or decreasing, and what the value of that slope is in this direction that we're asked to compute. So they've given us the definition of the directional derivative and a means to compute this directional derivative by virtue of this theorem 13.10. So let's compute first this directional derivative of u. This is going to be f of 3, 2 is what they're asking me about. That means I will compute the partial derivative of x at this point 3, 2, and the partial derivative of y at this point 3, 2. And my particular, I'm going to dot this. I'm going to find the dot product with my u vector, and in this case it is the u vector at point, the unit vector at point 1 over square root of 2, 1 over the square root of 2. So first up, let's get this partial with respect to x. This is going to be, these guys will be 0. This here with the x, drop the 2, be 1/2 x. So I'll just write x over 2. Fy, the partial with respect to y is going to be this x squared and this 2, and I take those derivatives, they're constants and they drop. That would be 4y divided by 4, so this is just going to be y. So I am going to be computing the dot product, which means at the point 3, 2, this is going to be 3/2, so I'll have 3/2 times 1 over the square root of 2, and added with at point 3, 2, this is just going to be a 2 times 1 over square root of 2. Getting common denominators and whatnot here, I'm going to get 7 over 2 square roots of 2, and if I do this computation on my calculator, I will get 2.47, which means that the function is increasing at 3, 2 in this direction. It's positive, so it's increasing, and here's the slope. This is how it's increasing, by the value 2.47 in that direction. Now I will do a similar thing for v, and then we will I'm doing the interpretation as we go, so let me write that stuff down for v. Alright, so there is my directional derivative with the unit vector v at that point. That would be at the point 1/2 and then negative square root of 3 somewhere over in this neighborhood. That means that the function itself, this function z, is decreasing at this point in this direction. So it's decreasing in a value of negative 0.98 in that direction. Our next topic is that of gradient. Now we found the gradient in our previous example. The gradient is just that partial derivative with respect to x and that partial derivative with respect to y, and it is a vector in and of itself. So it's just that part that we found whenever we were doing the dot product in that previous example. So let's find the gradient of f. So I'm going to take the partial with respect to x. That means that's going to be 2x plus the partial of this with respect to x will be 2y, and that is my x component, or my I component there. It's actually what it is. The next will be take the derivative of this with respect to y. That would be 2x minus 3y squared. This could also be written as 2x plus 2y I hat plus 2x minus 3y squared j hat. They want me to find this at the particular point 3, 2. So I'm just going to plug in a 3, 2 and compute, and that will be a vector. Alright, just doing that computation, and you can write it in either of these two forms. Next we're going to do the same thing again. We're going to compute the gradient of f, so I'll get the partial with respect to x, the partial with respect to y, and plug that in. Then I'm going to do this dot product. Okay, for the a part, I am just going to the gradient of f at the point, 3, it's just a 3, negative 1. I'm just going to plug that in here, and if I plug in a 3 for x and a negative 1 for y, and I'll compute that, and same thing here. Alright, there's finished with my computation. Now I am just going to do the dot product to get this directional vector here, 3, negative 1, or actually the slope of this directional vector, and I'm going to be doing negative 1/2, because there's my gradient times this unit vector, which is 1 over the square root of 2, add with negative 3/5 times this negative 1 over the square root of 2, and I'll compute that. Alright, and there is my directional derivative right here. That's the slope. I'm supposed to compute the directional derivative at the same point, but with this vector. Now they didn't give me a unit vector, so I'm going to have to get the magnitude of that. So that is going to be, the magnitude of that is going to be square root of 3 squared plus 4 squared, and that's going to give me 5. So that unit vector there is going to be 3/5, 4/5. To get that directional derivative, they didn't give me a letter, let's just call that v. F of 3, negative 1. We're going to say this is my v, and I will just compute that dot product. We now have the slope of the surface in the direction of this vector v. Surfaces that I'm looking at. I'm asked for the which direction should I move in order to get the maximum rate of increase. So here's my direction. They tell me what I need to do is find the gradient, so let's do that first. Let's look at the partial with respect to x. That's going to be 2x. Let's look at the partial with respect to y. That's going to be 6y. Let's get that value of that at that particular point. So I'm given f at the point 2, negative 1/2. So that's going to be the vector, 2 times 2 is 4. That would be a negative 3. And I need that unit vector, so computing that unit vector. So here's this unit vector, just finding that magnitude. And this is my direction. I should move with this unit vector. And the rate of change at this point, which they told me to just find the magnitude of that gradient, and that would be 5. In question B, I'm to find the maximum rate of decrease, so I'm going to be looking at this number 2. Very similar, I'm going to find the gradient at that point, and it will be very similar to what I just have done. Alright, just using what I did before and noting that it's just going to be the negative of those results. The negative of that gradient just changes the direction of the I and j components, and same with the unit vector, and that slope will then just be a negative value, and that would be the maximum rate of decrease at that point in the direction of that gradient. For the C question, I'm to find the gradient at that 0.31. I did that, so what we're really needing to find is where is it that my directional derivative in any direction is 0 or orthogonal to our gradient. So that would be these two directions with the 6, 6 and the direction 6, negative 6. Finding those unit vectors, computing the magnitude, I will get that equals 1 over the square root of 2, 1, 1, and also we'll just, this other unit vector would be 1 over the square root of 2, 1, negative 1. This next example is very similar to our last one. I'm going to compute the partial with respect to x and the partial with respect to y, and then I'm going to find the value at that point. Alright, and there's my A part. The next part, I'm supposed to find the minimum and maximum values. So what I'm going to do is find the magnitude of my gradient, and then I will talk about that angle. Alright, so you're going to end up with 12 square roots of 2 for your maximum value, and for your minimum value you're going to, so this will be my max. For the min, I'm going to end up with negative 12 square root of 2 is the slope of my decreasing. Note that this directional derivative here would have a theta of 7 pi over 4, and the one of minimum would be the 3 pi over 4 for my theta. In order to prove that we have the gradient at 1, 1 is orthogonal to the corresponding level curve, I'm going to have to find that tangent vector, and I will need to show that tangent vector dot product with that gradient at 1, 1 is 0. So first I'm going to need to find that tangent vector. So I will go ahead and figure out what z is at that 0.11. Z would be equal to 1 plus 2 plus 1, so z is going to be 2 at that point. So let's go ahead and state that 2 equals the square root of 1 plus 2x squared plus y squared. In other words, 4 equals 1 plus 2x squared plus y squared. And then I have that 2x squared plus y squared equals 3, and this is going to be the equation of an ellipse. I'm going to take this derivative with respect to x, and I will be able to find the slope. And plugging in the values for x and y at this, I find that the slope is going to be equal to, at the 0.11, the slope is going to be equal to negative 2 here at this point. So I know that my tangent vector is then going to be this 0.1, negative 2. I will take the dot product at this point, so that means I'm going to need to find the gradient of my f. Computing my partial derivatives, this is what I get. Now I'm going to plug in a 1 for x and a 1 for y, and then I'll do that dot product. And here I have computed that dot product and found it to be 0, which means that they must be orthogonal. Next, I'm going to find the equation of the line tangent to my level curve at that 0.11. And it follows from this that I will get, I'm going to plug in a 1, 1 for my partial with respect to x. I'll plug in a 1, 1 with my partial with respect to y, and then just do a little bit of algebraic manipulation. And there's what I get. I'm to find the projection in the xy plane of the path of the steepest descent. I have the negative gradient, and I now have the slope, and you will find that the path of this would then be 4x cubed over 27 would be the path of steepest descent. In this particular example, we are to find the gradient at each of these points. So I went ahead and did those partial derivatives, and we can see that at this particular point we have gradients that are all on the surface and they happen to be orthogonal. We can note that the actual rates, I'm going to just find the magnitude of each of these, and that will be the rates of change. So once I find the magnitude of each of those, then I'm finished with this problem. Here are the magnitudes of each of these. So this is how this slope is changing, and it is increasing at each of these different points. And that concludes 13-6, and that was a lot. Be sure and see me if you have